This presentation is going to be on what you do if and only when your ANOVA ends up rejecting the null hypothesis. So in the last video, which was on analysis of variance that demonstrated how to actually conduct an analysis of variance test, when you reject the null hypothesis, all you learn is that there is a difference, or at least one difference. But I did emphasize that you don't know where the differences are. To find the differences, you would do something called a post-hoc test. Post-hoc test is just a category of different types of tests. Post means after, hoc means after rejecting the null hypothesis from your ANOVA. And so it's only when you reject the null that you would do something like what I'm about to show you. On this sheet, which is the last sheet of your L13 handout, there's 3 formulas for 3 different types of post-hoc tests. I'm only going to teach the second and third one, the Fisher's LSD test, which is least significant difference, and the Chaffee test. The first one's a good one, but for the sake of time, I don't want to introduce a new statistic, which is this Q statistic. So you're already familiar with T used in the LSD test, and you're familiar with F, which is used in the Chaffee test. So those are the 2 I'm going to focus on. Before we get to applying these formulas, let's take a look at problem 5. So problem 5 wasn't one that I had shown a solution for in the video, but at this point you should have completed attempting the remaining problems on your own, and this was one of those. So here is the ANOVA table for you to check yourself. If you did it, great. Hopefully you got it. If you didn't, then you have this answer to step 2 in the hypothesis test for the analysis of variance. I will leave it to you to try to get these values on your own, but at least you know the values that you should be able to obtain. And the F statistic came out to 56.47. At the 1% level of significance, we want an F critical value at 3,25 degrees of freedom, but 25 isn't in our table. So F star 3,20 is the closest below it, which is going to be 4.94 for a critical value. Since 56.47 is way out in the right tail beyond the 4.94 critical value, we do reject the null hypothesis. So this is the perfect scenario for using a post-hoc test. The way that I tend to do a post-hoc test is I create a table like this, where my first column represents all pairwise comparisons that I might be able to do. So with 4 groups, compact, mid, full, and luxury, I could compare compact to mid, compact to full, compact to luxury. I could also do mid to full and mid to luxury, or full and luxury. And so that's where all 6 of these possible pairs comes from. The first thing that I obtain is the left side of all of these post-hoc test formulas. So I want the absolute difference of the means of the 2 groups that I'm comparing at any one time. So for example, compact versus mid. Compact has a mean of 667. Mid has a mean of 472. I wrote the averages below each of the corresponding columns. If you subtract one from the other and you take the absolute difference, the absolute value, you get 195. If you continue through, you get 213, 143, 143, 18, 52, and 70. Just to spell it out a little bit more, for 70, that is full versus luxury. Full has a mean of 454. Luxury has a mean of 524. And so when you subtract the 2 and you take the absolute value, you should get 70. So that's where this second column came from. The least significant difference is the bound on the right-hand side for Fisher's LSD test. So we need a T critical value based on half of the significance level, which in this case 0.01 is the significance level, so 0.005 is the column that we're going to be looking under, and the degrees of freedom is going to be the within degrees of freedom, which according to our ANOVA table is 25, right there. So we're going to be looking up 25 degrees of freedom row, 0.005 column. You should see a critical value of 2.787. Next, we need our mean square within, which from our ANOVA table is what I've got boxed out there, 1,145.76. So that's what gets plugged inside the square root. And inside the square root, that is also multiplied by the sum of the reciprocal sample sizes, again, for the two groups that we're looking at now. So that's compact and mid. Compact has 7 observations. Mid, we could see, has 10. So I wrote those as the second orange row here, below the averages. So you've got 1/7 plus 1/10. And when you calculate this, you get 46.49. When I look at the next pairing, that's compact versus full, the T critical value is the same, the mean square within is the same, 7 is still the sample size for compact, so I've got 1/7 there, but full only had 5 observations, and so that's where the 1/5 comes from. Calculate this, you get 55.24. As I continue on, 2.787 times the square root of 1,145.76, which is mean square within, times 1/7, which is the reciprocal sample size for compact, plus 1/7 is the reciprocal sample size for luxury. They both had 7 observations, and this gives us 50.43. And so that's where that value came from. The other 3 I've already put in here. You can pause the video at this point to see if you can calculate those on your own. I would recommend that just to be sure that you were able to get these remaining values. When you are ready, feel free to press play and continue the video. All right, so hopefully you have finished and you've hit play again, and that's why I'm speaking. In the 4th column, that's where I'm finally making a decision. I want to know if we reject the null hypothesis. According to this formula here, we reject when the left side is greater than or equal to the right side. So I want to know when column 2 is greater than or equal to column 3. 195 is greater than or equal to 46.49, so yes, we reject the null. 213 is larger than 55.24, so we reject there. 143 is greater than 50.43, so we reject there. 18 is not greater than 51.67, so we don't reject there. 52 is greater than 46.49, so we reject there. And 70 exceeds 55.24, so we reject the null hypothesis there too. So based on Fisher's least significant difference test, we find 5 differences. In fact, we can say that compact is the mean pressure applied to driver's side head during a car crash. In compact is significantly different from what is experienced in a mid-size, full, or luxury vehicle. We can also say that that pressure is significantly different between full and luxury vehicles. We could say that it's significantly different between mid and luxury, but not mid and full. And so that's how you can interpret this post-hoc test result. Let's go ahead and see what happens when we look at the Chaffee test. So the Chaffee test, we already have the left side, the absolute difference of the sample means for each of the pairwise comparisons. On the right, we need a square root of the between degrees of freedom, which is 3. We need inside the F critical value at alpha, not alpha over 2. So 0.01. Between degrees of freedom is 3. Within degrees of freedom is 25. And so when you look up f star 3 comma 25, you're going to see that 25 denominator degrees of freedom is not in our table. So I go down to 20, and the corresponding critical value is 4.94. So that's what I'm plugging in here. Mean square within is still 1,145.76. And the ratios are 1/7 and 1/10 for the first pair, 1/7 and 1/5 for the second, and so forth. When you calculate these, or at least these first two, you will get 64.22 and 76.3. So at this point, stop the video and see if you could calculate and get the other four values that I report in this table. All right, again, if I'm speaking, hopefully you attempted on your own and you were able to get these values. If not, please send me a message to get clarification, or attend office hours if you have that option. But we are looking at the same process in order to make a decision here. And so that is, if column 2 exceeds column 5, then we are going to reject the null hypothesis. 195 is larger than or equal to 64.22, so yes, we reject. 213 is bigger than 76, so we reject. 143 is bigger than 69, so we reject. 18 is not bigger than 71, so no. 52 does not exceed 64, so no. And 70 is not further to the right than 76.3, so we also do not reject the null hypothesis there. So I wanted to emphasize why I have taught you 2 post-hoc tests. You really only need 1, but it's good to be aware that post-hoc tests can give you different results. So even though both of these show that compact is significantly different from mid, full, and luxury, notice that the other 3 pairs were completely insignificant using Chaffee, whereas 2 of the 3, mid and luxury, full versus luxury, were significantly different according to the least significant difference test. The reason is that the Chaffee test tends to be more conservative. It's one of the most conservative tests, so it tends to reject less, which isn't a bad thing, but it's good to be aware of that. Both tests are well respected. Fisher tends to be used more often than not. The last thing I'll leave you with is that as you work through R on worksheet 6, R portion, you will see that in my sample code, I didn't use either of these. I used a function called pairwise.t.test. That is a pairwise comparison using 2 sample t-tests. It is another way to do it. It's a really easy approach in R, which is why I did it that way instead of the LSD or Chaffee test. But it's going to give you output that is going to be a table of p-values, and any of those p-values that are less than or equal to your significance level represent your significant differences. And so you look at the component in your row and column for that corresponding p-value, and that tells you which ones are different. With that, good luck, and if you have any questions, feel free to contact me.